Yay. All right, I think we lost half the audience from this morning. I blame the Serbian joint there in their rakia. So I guess all of you who are here did not have the pleskovica or rakia. So I was preparing for today and I was like, okay, obviously I have the toughest slot today to try to keep everyone awake after lunch. And of course, I was looking for some help with from ChatGPT, and there were like a couple of suggestions. One of them was to perform something. I'm not good at that, so I'm not gonna sing, I'm not gonna dance. The second suggestion was, okay, so try to engage the audience with some questions and ask them to clap or stand up or something. So I'm not gonna do that neither. I will jump ahead to the third suggestion, which I think was, well, much more plausible and would do the trick. Engage the audience by sharing a crazy number. By 2031, the OLTP and analytics market will go beyond $1 trillion. Can you imagine how much is that? I mean, it was difficult for me because it's just a number. Definitely a number that I don't have in my bank account, so I have no idea even how many zeros are there. So I tried to kind of relate it to something. So if you're fans of, Banitsa and Buza, this is like, what's that number? 400 million or billion? Billion. So we are in a 1 trillion market, so this is billion. And so I calculated this, by the way, with today's stock exchange, not stock exchange, but what's the number? Exchange rate for, left to USD. Then if you consider an average price in the US, that's like 200 billion beers. And looking at the prices of garage sales in Sofia, this might be like 5 garages in Sofia in 2030. So. All right. You are awake. Cool. So let's get to the topic of my talk today. Is Databricks ready for mission-critical OLTP? Who knows about Databricks? Oh, okay. Surprisingly, a lot of people. Cool. Great. So, to save everyone's time, nope, it's not. Now, if you're a manager or decision maker at this point in time, you might decide not to listen to what follows. But for all the other people who are interested, and geeks like me, why Databricks is not yet ready? Where is the industry going? That's my personal view. I mean, I'm not being sponsored by Databricks, and that's definitely not something I would say I've read or I've seen an official report of. So all personal, what's the word? Observations. So before we get to the reason or where the industry is going, I'd like to take you back probably 40, 50 years ago and just remind everyone what an OLTP is, what OLAP is, what is the modern data analytics landscape looking like, and then hopefully I'll be able to compare things and you'll be able to understand where exactly are we going. So OLTP. Online transactional processing, a term defined probably 40, 50 years ago. It's describing those systems which take care of the day-to-day operations of line of businesses. These are point of sales applications, these are CRM applications, these are those applications that take your orders online and whatever. These are the applications that generate the income, let's say, of a company. Oh, sort of say. Their purpose is to be fast, highly available. They have to be protected. I mean, can you imagine not being able to access your mobile banking? I mean, these types of applications are OLTP-based applications. They have to have millisecond performance. You can't wait for 20 seconds to get your bank statement. or to do a bank transfer, they have to be typically highly normalized. Everybody probably learned in the university first, second, third normal form. I know there is fourth, fifth, and sixth, which is only in the notebooks. I mean, I haven't seen it being used at all. And most of the times, OLTP systems are for structured data. Meaning, you have tables, you have to know the schema before you write into that table. You have to know the data types. You have to have primary keys, foreign keys, indices, and so on and so forth. OLTPs typically have, in order to secure high availability in disaster recovery, you have to either have it in a shared storage environment with high availability cluster on top, or some kind of replication, being data storage replication or database engine level replication. This is OLTP. Now, in the OLTP world, if you want to do analytics, you can't just run it on top of your operational database. I mean, I've seen a lot of people in like today, when we were back at HP, DXC now. So one of the main challenges there was figuring out performance on top of big SQL servers or big Oracles or whatever, where you needed to have both application and OLTP workloads and then analytics workloads. So back then, industry was doing, okay, so OLTP is here, we need to move the data out, denormalize it, implement some kind of clustering, indexing, and so on and so forth, so we can run our big analytics queries. Cool. That was good for, I don't know, probably 10 to 20 years, when you had your reports running on top of your structured data. But then the cloud came, data started to grow up. By the way, I think there was some statistics that probably 70 or 80% of the data that organizations collect is dark data. So meaning they collect it, but they are not really using it. So one of the big reasons was, well, we can't access it in an optimized way, or we can't analyze it in an optimized fashion. So then the data lakes started emerging. Data lakes in the cloud, you push whatever you have, whatever you like, and then figure out how you want to run on top some analytics. At that point in time, if you still had your data warehouse, you have to feed the data to your data warehouse from that data lake. So one ETL to move the data to the lake, and then another ETL to take it from the lake and push it to this data warehouse that you have. This is what most of the companies did. And if you're running data science or machine learning, then you run it in parallel, and you take data both from the lake, semi-structured, unstructured data, and some structured data from your data warehouse. Cool. But if you've been managing such kind of environment, you know this is a nightmare to manage. I mean, where is the source of truth? Is it in the lake? Is it in the data warehouse? Who owns the metrics? Is it the data science team, or is it the data warehouse team? How's the governance done? Where are the permissions? This whole thing started to kind of, well, generate problems for the industry and everyone that was moving into the cloud data management space. Hence, the Lakehouse emerged. Lakehouse as a term, if I'm not mistaken, Databricks came up with that original term. And what they said is, okay, store your data wherever you like. We'll put on top some governance, and you will use the Lakehouse as your single source of truth for whichever workload type you have, being that BI, being that operational reports, being that data science or machine learning or Gen AI applications for that matter. Cool. So Lakehouse, this was the new kid on the block for at least a couple of years. I think it still is, by the way. Now, the Lakehouse is based on an open source format called Delta. How many of you have heard about Delta? Okay, so pretty much everyone who was working with Databricks or heard about Databricks. What is Delta? Delta, again, as an open source format, it was developed by the Apache organization. And traditionally, if you look at the right side of the presentation, Row-based storage, which is Oracle, SQL Server, Postgres, all of those engines, they store data as a row format. And if you need to extract a single row, you just have to extract that physical piece from the storage. But for analytics, this is not very efficient. Because if you need to just aggregate one column out of 50 in your table, you have to read the entire table to just aggregate this one column. So Parquet is actually columnar storage, which says like every single column will be stored separately. We will run compression on top, encoding, compression, and so on and so forth. And if one needs to aggregate something, they will have to just read that physical piece of data. So for instance, if I need to do an average of age, I just need to read that greenish piece of physical data, and I'll be done. I wouldn't have to read all these other columns. So on the left-hand side, the row-based storage is optimal for singleton lookups, inserts, and so on and so forth. On the right-hand side, we have the columnar storage, which is good for analytics. So it's really fast, but on the other hand, if you need to do a singleton lookup to a columnar storage, that's a very expensive thing. It's again reading all the columns and figuring out which column, which row from that columnar piece belongs to that particular wider row. So we ended up in being either an OLTP system, which is row-based storage, or columnar storage, in this case Parquet. The same applies, I think, for ORC, which is the Oracle format. And Avro is not like that. So Parquet is generally the synonym of columnar storage these days in the cloud analytics space. So you end up with OLTP versus OLAP. And if you need to do any operation that is not native to that particular row storage, meaning singleton lookup versus analytical query, then you're doomed for a performance. You almost always have a performance challenge and performance issues. So how do you handle things? Well, you just start moving data. If you're going to do OLTP, split it into one RDBMS. If you're going to do analytics, move the data to analytics space and do dedicated tasks there. So that was like probably a year ago. And almost all organizations that I've worked with or that I talked to have been moving data from OLTP to OLAP and the other way around in order to satisfy performance and management challenges. And the industry right now is trying to solve this problem. Okay, how can we have a single platform, a single system that can deal with both types of workloads without this performance penalty? And I'm not entirely sure if Databricks is the first, but they're definitely one of the pioneers. And probably you're also wondering why on a Postgres-focused conference we have a Databricks being presented. Well, before I talk about Databricks and Lakebase, I have to talk about a company called Neon, which developed probably the first, decoupled storage from compute on Postgres. So essentially, you have storage, open source format, in any cloud-based storage, and then on top you have a decoupled compute, so you can run and scale as much as you'd like. This also brings you the ability to have serverless, meaning you don't have to run your own hardware in your own cloud subscription or hyperscaler subscription. You can run it anywhere. Because it's open source, it's not a vendor lock-in. And the product that these folks developed, I can't remember the name. So was it Neon? Yep. Yeah, okay, so Neon was the product. Now, Databricks, I think, merged with Neon or both Neon or invested in Neon. I have no idea how these things are happening these days. acquired Neon 6 or 7 or 8 months ago, and this got rebranded into Databricks Lakebase. And I think that's the first platform that actually brings OLTP capabilities into an analytics platform, which means that in a single platform, in a single solution, you can have either of those two. That's, I mean, a very good promise, at least. And what is another very innovative thing, I think, that I haven't really seen anywhere else is the ability to branch your database. How many of you have tried to figure out DevSecOps for database schemas? Only one? Were you successful? Any challenges? 90% successful, 10% I want to stop doing things. So with Databricks Lakebase, you're able to run an open source Postgres on top of your Databricks as a managed service without provisioning any infrastructure, clicking or, well, scripting things in the platform, and getting the benefits of running an OLTP grade performance applications. Cool. Yeah, but that's all marketing. When I heard this, so these were actually slides from the Databricks and Data and AI Summit back in June in San Francisco. And I was like, okay, so I have to present this topic. I have to figure to play with this thing. And when I started playing in the platform, it turns out that I can do only, I don't know, 20% of what was promised on the conference or what was announced on the conference. So sorry, I'm not going to be able to show you the branching and the Git related stuff, but I can show you how can you deploy a Databricks, a Postgres instance as part of your Databricks environment, and how you can run your applications or analytics workloads on top of that. So, right, there are a lot of things here, and I hope you can see properly. Cool. So, what I have here is a Databricks, traditional Databricks workspace. This is something, if you have Databricks, this is absolutely the same thing you can see today if you open a Databricks instance in your office. On the left-hand side, I'll have a catalog. Let me just quickly start it. So I have one catalog, which is essentially, you can consider this a database. So I have a database or a catalog in Databricks that hosts my Postgres data. And I have here one synthetic catalog. So I'm using one synthetic data we have to generate for one of the performance evaluations back at the office. And we are looking at, I don't know, the table that I want to show you and how I want to, the demo that I'm going to do is a table like 32,000 rows, not too much. That is stored in both Parquet format, but also Postgres, running also on Postgres. So first, how can you create or copy your data into a Postgres instance? If you go to compute, Lakebase Postgres here on the right-hand side, you just create a database instance. You basically have to point out just the name, how much you want to pay, how much you want to scale, and then how much more you want to pay. And you can configure some things like copy on write. This is copy on write. Oops, sorry. Create from parent is copy on write instance, meaning it's practically your production data, but copy it. And it's not the Git branch thing, but it's something it's still you can use for development purposes. And you can enable for high availability. So far, no DR. To be honest, I have no idea how to do DR for Lakebase Postgres. So that's one of the reasons that this is not the mission critical ready yet. So I create this instance. I already have one that is running. You can pause it anytime. You don't need it. So it's practically pay as you go. Well, not pay as you go, but pay as what you use. And you can even automate this. You don't necessarily have to run it 24/7. It's not very different than any other cloud provider anyway, but still something that you can do, especially for development purposes. The version 16, you can't really manage the versions. It's managed automatically by Databricks for you. So you run with basically what you get is what you see here. Very little, at least as of what I know, very little flexibility on what kind of configurations you can do. But these are the benefits of running a managed service versus, run it on your own. So I have this instance. Now, actually, let me show you first some performance stats. So I have this table, one fact table in Databricks, in Lakehouse, or in Delta format. And the Delta format is the Parquet files, if you remember, so columnar storage. If I run this, so I just started the Lakehouse, so no cache, nothing. If I run it, okay, so it was supposed to run for 4 or 5 seconds, but anyway, for a singleton row return, close to 2 seconds is still a lot. So this is retrieved from the Parquet files under the hood, and this is how the performance is looking like. So if you look at this, total of 2.5 seconds were spent to return the result. And 95% of this time was spent into optimizing the query and pruning files. What is pruning files? Basically figuring out which physical file, Parquet file, to read from the storage to return that row. Now, there are different techniques where you can optimize this, but this is 100% of the cases where the time is spent on query execution. Oh, it's 90%, not 95, as I said. And then the execution itself, you can see, it's just 56 milliseconds. So at this point in time, the bottleneck seems to be the storage for a singleton lookup. Now, if I want to see the query profile, oh, this is cached. Why are you cached? I restarted the server. Anyway, so essentially this goes through around 1,000 files, Parquet files, to figure out which one to read, and then push it to memory, and from memory retrieve this one row. Now, for an OLTP application, this is a nightmare. If you get 2 seconds for a singleton row to be returned, then your application will start getting locked. You start having performance challenges, deadlocks, and whatnot. Now, let's do the same on the Postgres. So I'll just do absolutely the same. So it's, what's that, half a second. Still not less than 10 milliseconds and stuff like that. But it's a public preview right now. So hopefully it will improve. But that's already way better than what we have for a typical Lakehouse operation if you have to do. So, cool. One of the other things that's very important for OLTP is being able to run transactions and have ACID compliance. Atomicity, consistency, isolation, durability. So all these things theoretically were available for Lakehouse pattern, and with the latest advancements of Delta format. However, it was still tricky. because you work ultimately with files, not so much with memory, and there aren't many things you can do behind the scenes to optimize this pattern. So even though you had ACID compliance on Delta, it's still challenging, not only for the performance, but also for the consistency of your data. So if I run, I don't know, a bunch of inserts, which typically in a Lakehouse might take, I don't know, several seconds, up to 10 to 15 seconds for this example. If I run this, I only get probably, again, less than a second. Where's the stats? Yeah, less than a second here at the top. See? 12 milliseconds. Or no, that's not 12 milliseconds, that's 120 milliseconds. So inserts work fast. Good. So we have the fast retrieval, we have the inserts. What about transaction handling? So let's say instead of a number, I insert a letter here. Yeah. Let me run this, and I'll have a question for you. When you see the result, do you notice something strange in this error message? Come on. Yeah, it says the column A does not exist, but A was the value that was inserting in that table, right? So that error message right now is not really the best. So it can get you confused. So be careful. But again, this is not production ready, so don't deploy anything in production. You know, you might suffer. And what if I want to do traditional analytics? I can still do it. And for typical report, like operational report things, it's still fast because it's reading row-based storage. Now, if this data starts growing, this type of query, when you have to aggregate a lot of data, is going to be slow, much slower. So at some point, there is a tipping point where you need to switch to an analytics engine. So how do you switch from a Databricks compute, or how do you switch between Lakehouse and Lakebase? So Lakebase was the OLTP, Lakehouse is the OLAP kind of a workload. If in your OLTP application, you need to synchronize something that exists or move data that exists in Lakehouse, you would need to do an ETL. But what Databricks did is they simplified this for you by automatically allowing you to synchronize these tables from the Delta format to Lakebase. And it's as easy as finding your table, let's say this one, and click Create a Sync Table. So what you have to do is you have to choose your database instance, which is the Postgres instance. And then you have to define your sync mode. You have snapshot, triggered, or continuous. Behind the scenes, this creates a Delta Live table or DLT pipeline, or I mean, I think it's a different name these days. But anyway, snapshot means you're going to take snapshot of that table and rewrite every day. Triggered means every 5 minutes get the new data and move it over, and then continuous means you're running as a streaming job. So the difference, essentially this defines how much you're going to pay, obviously, and how fast you're going to get your data to Postgres. But if you need to run a workload on your OLTP application that requires data that lives only in your Lakehouse, this is the way to do it, not by creating ETL jobs or something else. Let Databricks deal with this for you. Okay, so what if I want to run my analytics workloads and get data out of Databricks, of the Postgres? In this scenario, so that's the reverse scenario of what I showed you. So in this case, you don't even have to move the data. Databricks has this thing called Databricks Federation. So essentially, you run it against your Spark cluster compute, but the Spark cluster compute sends the query to the back engine, which in this case is the Postgres, transparently for you, gets the results, and present them to you. So for instance, if I want to run this same query, but instead of the Lakehouse, I want to switch to data stack catalog, goat. It was synced fact landing. Right now I'm using the Databricks Spark compute. So this is the SQL warehouse compute. Let's hope it works. Yep. Even though the data lives in the Postgres, I'm still able to run it in my analytics queries. This means also that I can run it with my PySpark, with my machine learning training algorithms or whatever. So this whole thing kind of starts converging. What else? Cool, so we showed this, transactions, we did inserts, we failed a transaction, and we did analytics query. All right, so I'm gonna spend some more time on this slide, and prepare for questions. I think I have 7 or 8. I will have 7 or 8 minutes for questions and an open discussion. So, industry right now is moving towards convergence of traditional transactional processing systems and analytical systems. With AI and agentic AI applications and all these I don't know, fashionable terms these days, it's extremely important to have your data accessible through a single platform. The less you do on moving data, the more you win on maintenance, keeping your data as close to the source of truth, and also getting the proper results. And I think all the big players on the market will move into that space, and they will want to grab this OLTP market, which, how much was it gonna be in 2031? 5 garages. So 60 billion in US dollars in 5 or 6 years is gonna be the OLTP market. So essentially the big analytical engines will try to grab that market and integrate as close as possible. I don't see the other way around happening as fast as the analytical space is moving. So if you need to figure out a strategy right now, think about this scenario. What is Lakebase good for? Well, obviously, to talk on conferences about it at this stage. In 6 months, probably it's going to be even more. It's not yet production ready, but when it is, you should think of using it for, first, application prototyping, faster development, because Databricks also offers you Databricks apps, which essentially lets you run any Node.js or Flask or whatever. I think there were a couple of other frameworks supported. You can just run it on top of a single platform. Forget about functions, Azure Web Apps, or whatever the alternate is in the other hyperscalers. Besides fast prototyping, a lot of the agentic solutions these days need fast access to data for singleton lookups. I mean, in term, what was the term? When you have to have online feature table available constantly, so that whatever prediction algorithm you have, it has to have real-time inference. You can't simply do this with keeping your data into a lakehouse. I mean, can you imagine waiting for, I don't know, 10, 15 seconds to get a recommendation? You would like that recommendation immediately. Imagine you're running on the stock market. Can you wait 15 seconds after an event to get a suggestion? No. So for machine learning scenario, agentic AI, all those features that require real-time inference, you want to consider the Postgres engine. I think that was one of the core reasons for this to be brought into Databricks. Before that, Databricks had their own Databricks online online features feature. Oh my God. But that didn't really work well. So they decided to bring in Neon to help with the manageability part and the cost part. Analytics. Obviously, you want to run analytics and have some master data living in, I don't know, in some MDM or RDM, reference data management systems, that do not necessarily will be in Lakehouse format, in Delta format. In those cases, if you need faster lookups, faster joins to nomenclatures and reference tables, you want to use Postgres. One not very popular application for the Lakebase Postgres, but still very useful, is serving data, or allowing applications, external applications, to get data out of Databricks for whatever reasons that they might need them. Imagine you're keeping your entire data estate into Databricks with Unity Catalog, including federation and whatnot. And you have downstream applications who consume data for either analytics or some predictions, like real-time inference, or they need to, I don't know, get the data through an API. All this is supported by Databricks. But how are you going to meet the performance? Lakebase is the feature that would allow you to meet sub-second performance for all those singleton lookup scenarios. Imagine that you have an application that needs to do a REST API to get, I don't know, the salary of a person by his ID, right? In a Delta format, that's not going to be fast enough. You typically expect less than, I don't know, a second performance. With Lakebase, you can achieve this. So you can use this to actually serve your data out without buying third-party product to virtualize your data or to just expose it as an API. Obviously, you can use fast API or whatever else is available on the market, but that just complicates your architecture. If you don't have that much of a demand in terms of performance, like for instance, for medium queries per second, medium scale queries per second, and not so low latency, then Databricks and Lakebase can meet these expectations. Where I don't see Lakebase to be helpful, definitely not mission critical OLTP, where you require high availability and disaster recovery. It's still a managed instance. Managed services are great when they work. The moment they break, it's a nightmare to recover. If you need to run secure, highly regulated applications like HIPAA, FedRAMP, and so on and so forth, Lakebase is not yet ready. So I'll pause here. We have 7 more minutes for any questions. Oh my God, no questions?
It's not that bad if no questions. I mean,
no, okay.
This means no one understands anything, or everyone understands everything. Right? So
yeah, I doubt that I explained things that good, so everybody understood everything. So I guess people are just shy.
Wait. Can you ask on the microphone so it will be on the stream? To be on the.
I still didn't understand. Are you working for Databricks or not? Are you an affiliated person or not? Or you are like very good independent specialist making review?
Okay, cool. I am not working for Databricks. I am not affiliated with Databricks. I run, actually, yeah, so these are my contacts. So right now, my day job is I work at the World Bank in the Sofia office, and we deal with data platforms. So Databricks is just one of the things me and my team run, and that's how I get my experience with the platform. I also run the Databricks user community, because with the rest of the founders of that community, we believe that knowledge sharing is the key to succeed, especially when well, there is so many online sources that you get confused sometimes what to read from where, and if that's even true, what you read. So to answer your question, again, no, I'm not affiliated with Databricks.
However, I can ask because I'm one of the Java user group leaders, and I had like, I don't know, 6, 7 clients about Java just indirectly because I'm involved. So sometimes when you share or when you participate in a user group, this means that you might get consultancy opportunities or some other opportunities. So there is a value even if you are not directly involved with Databricks. So that's why most people should join some user group, depending on the technologies that they like or they use or they want to use. Any other questions?
Okay,
Nope?
I guess I
thank you.
could have had the 30-minute slot, not the 45. But anyway, so
Yeah.
thanks everyone. My name is Ivan, and I hope you enjoyed the session.
Thank you.